Space exploration reached a new milestone on March 12, 2025. A SpaceX Falcon 9 rocket soared into the sky. It carried a precious payload, NASA's SPHEREx telescope. This launch marked the beginning of a groundbreaking mission. SPHEREx will create a unique three-dimensional map of the entire universe. The launch was a joint effort between NASA and SpaceX. This collaboration highlights the growing partnership between government agencies and private companies in space exploration. The Falcon 9, a reusable rocket, has become a workhorse for such missions. Its reliability and cost-effectiveness are changing the landscape of space travel. The successful deployment of SPHEREx into its planned orbit is crucial. The telescope will embark on a 2-year journey, its mission to scan and image the entire sky. This ambitious goal promises to unlock new secrets of the universe. Scientists and astronomers eagerly await the data SPHEREx will gather. SPHEREx, short for spectrophotometer for the history of the epoch of reionization, is not your average telescope. It's designed to do something extraordinary. Imagine taking a panoramic picture of everything in the sky. That's what SPHEREx will do, but with a twist. Instead of just capturing light, SPHEREx will analyze it. It will break down the light from every star and galaxy into its individual colors. This process, called spectroscopy, reveals vital information about the objects being observed. It's like looking at a fingerprint. Each celestial object has a unique spectral signature. By studying these spectral fingerprints, scientists can learn a lot. They can determine the composition of stars and galaxies. They can estimate their distances from Earth. They can even track their movements over time. This data will help create a dynamic three-dimensional map of the universe, a treasure trove for astronomical research. Spectroscopy is at the heart of SPHEREx's mission. It's a powerful tool that allows us to study the universe in unprecedented detail. Think of light as a messenger from distant stars and galaxies. This light carries valuable information about its origins and journey through space. SPHEREx will capture this light and split it into its constituent colors, like a prism creating a rainbow. Each color corresponds to a specific wavelength of light. By analyzing the intensity of these wavelengths, scientists can decipher the chemical composition of the objects emitting the light. For instance, the presence of certain elements like hydrogen, helium, or heavier elements will have distinct signatures in the spectrum. This tells us what the stars are made of. The way these spectral lines shift can also reveal the object's motion towards or away from us due to the Doppler effect. SPHEREx's observations will be instrumental in addressing some of the biggest questions in cosmology. One of the primary goals is to understand the early universe. By looking back in time, which is possible because light takes time to travel vast distances, SPHEREx can provide insights into the universe's infancy. The mission aims to detect the faint glow of the first stars and galaxies that formed after the Big Bang. This will help us understand how the universe transitioned from a hot, dense state to the structured cosmos we observe today. SPHEREx's data will be crucial in studying cosmic inflation. Cosmic inflation is a theory that suggests the universe underwent a period of rapid expansion in the first fraction of a second after the Big Bang. SPHEREx's observations will help test this theory by looking for specific patterns in the distribution of matter and energy in the early universe.